Hi.
Hi.
Please introduce yourself.
Yes, I'm Jörg Hofmann. I'm a shareholder and CEO of the company BSC Computer. And we show here a complete new product. It's a dielectrical elastomer actuator. It's a piece of silicone. And you can move it by adding energy. So we can look at the demonstrator. This is a dielectric actuator. And when I give energy, high voltage to it, then it shrinks. And also, if I take the energy out, it expands. So this is an easy way to use this for linear motion. We have the first products that will come this year. For example, lockers. So we have no motor, no gearbox. And this is the electronic part where we make from 1.5 volts up to 800 that we can control the dielectrical stack. So, and we also provide for other solutions the electronic that is able to control dielectrical actuators. These actuators are not only for linear motion, like shown in our sample here. You also can use them as an energy harvester. You can make energy when you shrink them.
So it's bidirectional?
Yes.
You create the energy and you use the energy to trigger them.
And you get more energy back when it expands. And the
more energy?
More energy back, so it's an energy harvester. You can use it for energy harvesting.
If you put it in a shoe,
for
and you
example,
walk on it.
Yes, then you can produce energy.
And you're going to charge your phone like this?
Yeah, this so much energy is not, then you need really big shoes, I say. But the next thing is, it's also a sensor. So you get back the information, not only that you control it, you get the information back about the capacity of the actuator. And so you have information about pressure or something like that. This is also an energy harvesting rocker switch from the company Enotion. This makes the energy with an electromechanical part. But you can also control this
with a Bluetooth low energy?
No, I show you. We have, this is a development kit we are providing so that if someone is interested to do his first steps on using this technology. And this is connected to IoT or to internet. And you can use a browser and control the stack. You see, you control the stack with a browser, or you can control it maybe with a slider. So I say move only 50%. So you have the possibility with software that you can say how fast the stack is moving if you want to use it as a pump, maybe 50 times in a second. Or fast shrinking and slow expanding. Everything can be controlled on a web portal.
So this technology here is unique. Nobody's doing this before.
No, this is we are the first that are now able to deliver and produce these stacks.
Who's the inventor for this?
The technology was already described by Mr. Röntgen 100 years ago, but he said we cannot produce it. We know about it, but we cannot produce it.
He said it was impossible.
Yeah, to produce, but he described the functionality 100 years ago, but they cannot produce foils with 15 millimeters, or they do not have 3D printing, what we have today. And they have no high voltage electronics. But today, we have everything that now this technology finds its way in the first products.
You're the first?
Yes. We start with lockers, and a lot of other products are coming. And interesting is the way you need for the movement or the power, this depends how the stack is built. You have maximum 8% of weight. This means if you have a stack like this that is 50 millimeters, you have 4 millimeters weight. For this, that is 20 millimeters, you have 1.6 millimeter. This one has 10 Newton power. If you want to have more power, you make the stack bigger. So if it's bigger, then you have more power. If it's longer, you have more weight. And the next is how much voltage you bring in. This is also depends on what the weight is, what the power is, how fast it is.
So in the future, there's going to be a lot of energy harvesting in the world.
Yes, every energy harvesting is for all sensors and some use cases very important. And one of the really important part is the dielectrical actuator needs low energy to move. For example, if you have a normal lock with a motor and gearbox inside, you need a lot of energy that the motor starts. But we need so low energy that you can use the energy from the smartphone, NFC, that within a second you give energy enough that you can open a lock. So the starting energy is really low.
So all the locks need no batteries now?
Yes.
Smart locks, finished, no battery needed.
You have control, security on the smartphone, the app, and you say open, and then the energy is transferred, and the lock is looking, is it allowed or not? And so you can have a cloud solution that you say, if someone is coming, yes, he can open. You have the complete information. Who is it? When do we open? When do we close? This is a classical.
When you move the handle on the door, can give the energy also?
This is difficult because the movement, the way is not enough. So it's easier that you have something like a smartphone that gives the energy out.
All right.
Possible is, it's the same like this. You make the energy for the signal, for the radio, when you press it. So you see, we control the stack and we just press it and it makes enough energy that the radio gives the information, open or close.
Is this the most efficient system for both moving from energy and energy harvesting?
At the moment, I say this is a complete new world of linear motion technology with such a low energy consumption.